Alrighty, let us get started. So today is the final exam review for this course. Um, let's see, I was looking and it looks like the final exam itself, shoot, I was just looking at the date and I have already forgot. Let me look it up really quick. Final exam schedule, Friday, May 6th. So, final exam will be this Friday. The way it'll be run will be online, just like our mid-semester tests were. So no change to how to actually do the test. The test will be posted onto Canvas in the morning of Friday. You download it, work it out either on the test pages or on a separate sheet of paper, and then submit it back by 11:59 p.m. that night. The format will look the same as the previous tests. The only difference being that since this is a final exam review and its final exams on Dillard's campus are 2-hour exams rather than 1-hour exams, then you can expect about twice as many problems. So since our previous tests had 6 or 7 questions each, then you can expect about 12 to 15 problems on the test. It is cumulative, so that means it goes over all the topics we've discussed over the semester. Basically, it's a way of saying, okay, you've gone through the semester, now let's just see what you remember, what you've learned. Let's see if you understand the topics we discussed. So there won't be any new topics really at all, other than the topics we discussed in the course. Of course, one of the topics we did not get a test on just because we kind of ran out of time at the end. And I preferred to give you the topic rather than to give you a test and try to rush through it. But other than that, you've been tested on the previous material. And of course, we've gone through all of the material. There's no independent study stuff that you'll find on this test. Everything we've gone over in class. So also, as I said, the format is the same, all actual calculation questions. So show your work so you can get partial credit if there's anything wrong. Definitely have a calculator. That way you can actually give the complete answer rather than, working out problems and that's it. So let me go ahead and go over what topics you can expect to see on the final exam. Obviously, they are all the topics we discussed over the semester, but I would say it's kind of broken up into 3 parts, 3 major topics. The first was electricity. So this is what our first exam was about, electricity. And for that, we had things like the Coulomb force. This is, you have a couple of charges placed next to each other, and you'd like to find out what force do they feel due to the other. That is, if you have 2 electrons placed close to each other, they'll feel a repulsion, and you want to calculate how strong is that force. And the equation for that force is K Q1 Q2 over R squared. And a big thing to remember is that this is a vector force. So we have to keep in mind X and Y components. If you have a charge here, a charge here, and a charge here, and the question is, what's the total force felt on that charge Well, you'll have a force due to this charge and a force due to this charge. One is in the X direction, one is in the Y direction, and we saw how to handle that. Also, we had circuits. Basic circuits. And for circuits, we had a few different things we had to know. Firstly, given a circuit with multiple resistors, we wanted to know how do we find the total resistance. And so you had things like the total resistance of series connection is just the sum of the resistors that are in series. You have a circuit, and you have a couple of resistors connected by series. Then you just add the two resistors together. That gives you the total resistor, the total resistance in series. And for parallel, it's you add the inverses instead. 1 over R1 plus 1 over R2, and so on. And then, of course, you can have a circuit that has a combination. So some of the resistors are in series, some of them are in parallel, and you have to, little by little, add the resistors as they should be added till you get the total resistance of the circuit. Once you know that, then you can use Ohm's law, V equals IR, to calculate, let's say, the total current which should run through the circuit. If you know the voltage of the circuit and you know the total resistance, then you can calculate the total current that would run through. And in power, the power of the circuit is I times V, the current times the voltage. And so we saw we had some basic circuits, no AC stuff, only DC, and really kind of low-level versions of circuits. We're not getting into any of the more advanced techniques like loop analysis or nodal analysis or all sorts of stuff. That comes later. This is just an introduction, and so we want to know the basics. And the basics are, you have resistors connected in series and parallel. Do you know how to combine them appropriately? And when done, can you then use Ohm's law to calculate some other stuff like the current or the power? And that was our first test. That was the first big topic, electricity. From there, the next test dealt with fluids. Now with fluids, what we had was first one, Bernoulli. So Bernoulli's equation, Bernoulli's principle, was the equation that we used when we dealt with things like pipe systems. You have a pipe, water flowing through the pipe, and the pipe has the ability to constrict or expand, change size. Also, it could move, so it could go up to the second floor or down to the basement. And you'd like to find out, let's say, about the pressure. How does the pressure change in this system when all of these things are done? And we saw that this equation looked like this: P1 plus 1/2 rho V1 squared, which was the term that dealt with how fast the fluid moves through the pipes, which of course deals with the size of the pipes, plus the rho G H1, which is the term that dealt with how the pipe moves up and down, is constant. So P2 plus 1/2 rho V2 squared plus rho GH2. You have a system. It starts in one way, ends in another way, and you want to know, how does the pressure change? That's what this equation allows you to do. And then we saw that in order to use it, sometimes we need a second equation to help us out, because let's say the pipe